Welcome to the Meltzone podcast. This is episode 35 from May 31st, 2020. I'm Tom.
And I'm Stefan. And I finally got myself a mini lathe. Tom finally got a Prusa Mini, and yeah, he did a couple of live streams, and one of them was the Prusa Mini unboxing a couple of days ago. And yeah, it's an interesting machine. Fellow French YouTuber Heliox got her YouTube channel stolen by somebody we don't know, and we just talk a little bit about how it would be kind of having your livelihood taken away just overnight, and a couple of things that you could do or that you can also do to save your precious social media accounts or anything else that is related to internet security. Researchers created an ultra-fast nozzle-based 3D printing technology where they use a filament that is statically charged and kind of guided in a way as the electron beam in a CRT is guided. And yeah, we have a couple of thoughts on that. And then next, carbon nanotube coated filament for heating it up at the location where you print to have better adhesion between the layers. That's something that could be the future for really strong 3D printed parts. We'll see.
And you know what you could use those really strong printed parts for? For accessories that Miele, a German appliance manufacturer, has posted on Thingiverse. Some of them are more useful than others. We'll look at what they've done and, some of the implications that has. We have a topic of the week again, finally. It's been a while since we've done that. And this week we talk about, we're doing 2 weeks. To 4 weeks per episode. This time we talk about printer maintenance and all the things that you should regularly check over on your machines. Adrian Bowyer has sent me a DM correcting me on some of the stuff I said last episode with regards to his concept of a quick release bed. And lastly, we take a question about filament width sensors and how useful we think those are. Stefan. Stefan, good to see you again.
Yeah, sorry for being so busy. The last weeks have been horrible, and I'm sorry that I just didn't manage earlier to find a bit of time to record the podcast. And I think there are quite a couple of topics that have piled up over the weeks.
Yeah. Well, let's get started with the first one. You got yourself a lathe. You got a mini lathe. Congratulations.
I got myself a mini lathe, even so I currently I don't have any time for it, but I want to have a mini lathe since like forever. And then I think 1 or 2 years ago, this old Tony posted a video of the mini lathe, about the mini lathe. And I said, I want to have one, but I don't have the space and stuff like that. Turns out 2 of my friends also bought themselves a lathe, and I just couldn't resist anymore. And to be honest, there have been things over the last years where I thought, why don't I have a lathe at home? Sometimes it would be really useful. Yes, all right. And my wife is also asking me that from time to time. For what do you actually need a lathe? I can't really say when I'm going to be using it. I kind of have a couple of projects in my mind, but just sometimes you think, now it would be great to have a lathe and just turn something down. Or I don't know. I bought myself.
You got one. I've had one for probably, 8 years, 10 years or something. Probably 10 years now. I got the slightly smaller version. I got the 310 millimeter long one. You got the 400 millimeter length.
Yeah.
Some people get offended that you even call that thing a lathe because it's so tiny. It's like the smallest possible version of something that resembles a lathe and works like one. But it is surprisingly capable if you have the right tooling and if you figure out how to use it.
Yeah.
Like traditional machining rules kind of don't apply anymore.
Indeed. Well, maybe first point, the Proxon lathes are even smaller than, or the smallest Proxon lathe. Yes, they are not the strongest ones. Mine has a 500 watts motor. The smaller version even only has like a 250 watts one, so that's not a lot.
Yeah.
But if you're not really taking deep cuts in, I don't know, steel, it is usually fine. And this thing is so wobbly that you won't be taking deep cuts in the first place. So I don't know if I'm going to regret that, but I basically took it totally apart just at the minute I got it. Didn't really, try it out. I wanted to clean it up and put some proper oil everywhere and just tune it in. It is a Chinese machine. You definitely notice that.
Yeah.
And things need to be, a couple of things need to be fixed, that everything has little play and is not wobbling around that much. But I did a small part in brass and it looked fine, and I enjoyed it.
Brass is nice to work with.
Oh yeah.
On mine, the motor has been kind of messed up for a while, and I recently had a look at it, and the bearings are all completely wobbly in the plastic motor caps. I think the bigger motor might be better. I don't know. So I'm gonna have to get a replacement for that, and also the what is it named? The cross slide.
Yeah.
And the parallel slide?
Compound.
Yeah.
Well, compound is the most upper one.
Right. Okay. Yeah. Anyways, those two that you have on your carriage, those have been super wobbly for me as well. So it's just a bit of adjustment with the nuts. Actually, is it that you have to tilt the nut to actually engage the threaded rod properly, or the lead screw?
Yeah. Mine has a really nice mechanism for those. Are you talking about the automatic feed, or just
not the half nuts, but the actual nuts that engage the lead screw on your manual crank?
So for the cross slide, I think it's just it's a steel nut which is fixed to the carriage, and the nuts in the compound that's directly integrated, and that's currently giving me a bit of trouble because it's not properly aligned to the lead screw. I still enjoy working on problems like that and trying to figure out how to get it properly running. And I currently now have 2 weeks of vacation, so I hope that I find at least a little bit of time to get it running properly. Yeah, bought a lot of equipment to it, like a college jug and a multi-fix tool post thing to quickly remove tools.
You get a quick change right away. That's one of the things that I'm still holding out on, because they are quite expensive if you get a proper one.
Yeah.
You getting carbide tooling?
I just bought carbide tooling because I don't want to fiddle around with grinding high-speed steel, even though the problem with working with carbide is that it needs to have kind of a fast cutting speed, and this is sometimes hard to do on those small machines. I don't know, we'll see. Otherwise I'll just buy myself a couple of high-speed steel bars and grind my own tools.
Yeah, I mean, I've still got some if you want to try them out. I got myself a few Wendeschneidplatten holder. What are they called? Insert holders. Yeah. Insert tooling. And actually, it's not been a problem to use those at all. Yeah. The only problem is, again, if you have backlash in your slides, and your carbide tool catches, like that insert is gone. Like, there's nothing to save it. But yeah, in general, they've been pretty good. So.
Yeah. We'll see. It's just another tool in the workshop. I still need to figure out where I can properly place it, but I don't know. I sometimes need to do different things just to keep me happy. And I haven't been using a lathe for 13 years, I think. And I was really enjoying it when I did it before I started doing my bachelor's.
You actually have formal lathe training?
I had formal lathe training for 4 weeks or something like that.
That's something.
I didn't do an apprenticeship, but, well, Didn't you also had to do that before you did your
no,
studies?
Because I had started a business before I started studying, so they that was accepted as your
that's enough of an internship
experience. Yeah.
So we were like for 3 months in our machining shop. So we started basically from filing parts to drilling to tapping to everything that you usually do in a machining shop. And then we also used mills and lathes and stuff like that. And I just really enjoyed working on those machines, even though they were 50 years old, but they were great.
I mean, that's the best ones, right? Everything is still manual and you still need to know the machine to actually get it working for you.
Yeah.
No digital readouts, no trickery like that.
Yeah. Yeah, we'll see. I still hope that the Mini Lathe can spark joy in me, how Marie Kondo is saying.
yeah, it definitely will. Get it cleaned up, get it adjusted. You've already got the collet chuck. Like that's a good one. Get some nice tooling.
Yeah.
And it's definitely very usable.
Yeah.
If anything, it's better than not having a lathe.
Yeah, definitely. Yeah, but you have also been pretty busy. So you're currently preparing your basics series that is starting next week.
Yeah, already in full production. So the first 2 episodes are planned for Friday, and then for the rest of June, we'll have a total of 10 episodes out. Covering, the idea is covering everything that a beginner is going to need to understand 3D printing, pick the right machine for them, understand a few slicer settings, all that. Because I don't know if I said it before, but Hackaday complained about getting into 3D printing being too hard.
Okay.
And being, there's too much taken for granted. So that's the plan. Basically, explain, okay, this is a hot end, that's a nozzle, that's how they work together. That sort of level of information.
Okay.
So yeah, that's in full production. And the 2 unboxings that I did, was it yesterday? No, day before yesterday? Day before yesterday.
Day before yesterday, yeah.
Day before yesterday and the day before yesterday, where I did the Mars Pro, which is behind. I don't know if you can see that. Yeah, it's exactly behind me right there. Got the Prusa Mini out of the box. People were like, hey, how did you get a Prusa Mini? Well, Prusa is sponsoring the series as the filament and filament printer sponsors. So I was like, dude, if you're gonna sponsor this thing, like, I better have a Mini. They're like, okay, fine, we'll send you one.
They're currently like 4 months
September.
on back order.
Yeah.
Oh yeah.
It's rough. I mean, they've been obviously impacted by COVID-19 shutdowns. They're ramping up production again at where it is safe. But obviously, people haven't been buying any less 3D printers during lockdowns. If anything, they've been buying more.
Yeah, I think so as well, because on the one hand, people had more time, and there were, well, I know a couple of guys that bought themselves a 3D printer just to be able to print face shields, for example.
Yeah, that also goes into that.
So cool. So it's going to be a 10-part series every week, yes. 2 episodes.
Yes, it's going to be brutal. I mean, I have no illusions about that. Whereas usually I produce a video every 2 weeks or so. If it's on the best of times, I'm doing 2 per week. But thankfully, it's not like a review where you have to do a ton of upfront research and work before you can even start scripting. This is just information that I'm just putting from my head onto into Google Doc in that case. And yeah, so I can script those. I don't want to say easily. It still takes a lot of time to structure that properly, but yeah. Biggest video project I've ever done.
You probably need a vacation after that.
Probably, yeah. We're already skipping the bike tour with my dad this year.
Okay.
We wanted to do France, the West Coast.
Cool.
But yeah, obviously travel isn't. Well, it's slowly ramping up again, but at the time when we were deciding, okay, we're just not going to attempt it, it didn't seem like it was a good idea, and I still don't think it is.
I don't know. So Pfingst vacation is currently starting, and basically all the years in the past, we have at least gone for 1 week or something like that on holiday, just to Italy or to Austria or something like that. I kind of miss it at the moment. I would be really happy to just be somewhere where I can think about something different. But nah.
Yeah.
Have some good food, nice views, and maybe some workout, because I'm still getting fat.
We all are. We all are. Trust me.
But as I have already told you before we started recording, our renovation work is starting in the house, and that is keeping me busy as well. And some of the work I'm just doing around the house is also kind of an exercise, and that's kind of a good thing to get your head free, and well, in comparison of sitting in front of your screen all day.
For sure. Yeah. So you were mentioning you're planning to do solar. They've I've been wanting to expand my system as well, but one of the looming swords of Damocles, is that something that translates into English? Whatever. One of the looming dangers was always that the feed-in tariff, the guaranteed feed-in tariff, basically was capped in Germany, and it looked like around this time of the year, if your system went into operation after that, you would not get any cash for the power you feed into the grid. Thankfully, that has been cancelled now, and it's gonna you're still gonna get that feed-in tariff. How much it's gonna be, I don't know if that is still if that has been decided yet. But at least we can go ahead and plan new solar arrays.
Cool. So
if there were panels available.
Okay, is that seriously a problem at the moment?
Yeah,
okay.
for sure. If you look at the solar shops, I mean, you can go on a bunch of shops and basically wholesalers. You can get like a couple of panels, a couple of types of panels, but like the majority of them are out of stock.
Okay. So well, the idea was, since we are basically putting a new roof on our house, and with that new roof also adding a third floor to it, we have scaffolding all around the house, and that would be a great opportunity to put solar on the roof, because you don't have to worry about falling off the roof when you install it. But if you're saying that getting those solar panels might be a problem, and the question is if it's worth waiting for the next year, because if supply is currently that low, probably prices are also up quite a bit.
Well, the thing too is, if you're waiting for long, the feed-in tariff is going to go down. Well, at least that's how it's been working for the last few years, where basically every month it's been dropping by 1.1 cent.
Okay.
So if you wait a year, you get like 1.2 cents less for the power you feed in.
Yeah.
So at some point, really, it's just going to make sense to consume as much power yourself, which for my setup, it already is.
Yeah.
Yeah. Talk to electrician, to your solar dude, and maybe he knows a guy who still has some panels.
We'll see. Yeah, but you're still charging your Leaf, or do you now have another electric?
So the Leaf is getting sold to the Peugeot dealership on June 8th.
Yeah.
So in a bit more than a week. That will be gone. Right now it's still plugged in and it's being charged. And then we will see at which point I'll get the E208, because, Peugeot factories were shut down as well. So they planned to have it available end of May,
okay,
in May. And right now I don't know if they already have a delivery date. But yeah, Leaf. I've ranted about that before.
Yeah, I won't start you on that.
I might do a video just about the solar array and Leaf, because the solar array has done 20 megawatt hours now. After a bit more of 2 years of operation.
Cool.
It has produced 20 megawatt hours of electricity.
That is quite a bit more than you probably use.
Yeah, so it's enough for about 4 households.
Cool.
Yeah.
Even though you're only having 5 kilowatt peak on your roof, or how many?
9.7.
9.7. Okay, and you want to go over the 10 kilowatt?
I wanted to fill up every last spot that I that I could find. Probably go on the garage roof as well, and go up to 30.
Okay.
Because 30 is the maximum limit that the grid operator is allowing me to have.
Okay.
Because they say, okay, if you have more, you're gonna actually overload our grid. Like every second house on the street already has a bunch of solar from like the early 2000s.
Yeah.
So yeah, we do have a bit of feed in happening. Actually, my entire Gemeinde, the municipality, is producing more power than we're using. More renewable power than we are using in the entire municipality.
Again, even though you're living next to a nuclear power plant.
Well, that's a different county even. So.
Yeah. Cool. Yeah, we'll see when our renovation is really starting to happen and when it's finished, and if I get solar on my roof. We'll see. I'm really looking forward to having my studio expanded, because currently it's totally everything is cramped in here and it looks horrible, and I seriously want to do some renovation work in here, and maybe even like in thinking about the channel name, put a real kitchen in there and have a kitchen backdrop for filming stuff.
Have a Linus Tech Tip set, yeah.
Yes, definitely. A fake window somewhere. I would really enjoy that, but I don't know if that's going to happen.
I mean, let me know if you need a hand. I'd be up for that.
You have already been installing an IKEA kitchen, didn't you?
Yes, yes. 4 meters, exactly.
4 meters, yeah.
Took a bit longer than expected, but...
we did that as well when we moved into that house, because we wanted to save some money, but all walls are not straight, and it was such a pain to get everything in there. But even though, if you don't take the most cheapest IKEA kitchen, I'm really happy with it for the price. Super good.
Oh yeah, me too. Me too. I mean, I've got not the most basic fronts, but just the plain white fronts.
Yeah.
Ton of drawers, but yeah, if you got a different kitchen, it would have been like 3 times as much.
Yeah.
Welcome to the Meltzone Kitchen Podcast, where we talk. I mean, we could be melting chocolate and stuff, right?
Yeah.
Channel name still applies.
No.
Anyways, let's get into a few topics. Shall we?
Definitely. First topic that also, struck me a little bit. Maybe you guys also know the French DIY 3D printing YouTuber Heliox. And it was, I think, 2 weeks ago or something like that. She posted on Twitter, guys, I can't log into my YouTube channel anymore. Somebody stole it, and they they have put all of their videos on private, and just added a message there. Okay, if you basically want to have your channel back, you need to pay us X amount of money of Bitcoins. And that is quite scary when something like that happens. And she also has like 250,000 subscribers, so she's probably basically also living from her YouTube channel. And if just you wake up one morning and everything is gone.
Yeah, need new underwear after that for sure. So do we have any details? I mean, the post is French, and I'm not finding the translate button here on Twitter. I don't know why that is. But do we know how this happened and what the point of entry was?
I don't know that. She made a video after she got her channel back, but since my French is not that great, I didn't get what was really happening. But it seems as if she was able to figure it out directly with YouTube, and also with the help of some other YouTubers that got her heard at their channel managers, and they were able to give her access back without her losing her content and paying some thug money.
Yeah, so I guess the lesson to take away from this is don't reuse passwords. Enable two-factor authentication if you can. Keep your Windows updated, because I mean I'm seeing some comments going like, "Hey, install malware bytes, whatever, on your computer and check for viruses." But typically, I think this is just either a leaked password or brute force or some other social engineering approach.
Yeah. So you would actually think if you have two-factor authentication activated, it's really hard to get access,
right?
But well, I don't know if she had or had not, but there might be some ways around that, either by having something installed on your machine and using that kind of as a proxy, or I don't know, but
true.
It's just making me scary. And when we talked about that before we started recording, you also told me something about this wannabe YouTube friends thing that popped up, and which I have also seen that comment on a couple of other channels. But I don't know. Can you just explain that a little?
Yeah, so apparently there's not a ton of information about it. There's this one video by Even Z111 or someone who's explaining it. And apparently there is a YouTube channel under the name of Logan, but the name apparently has changed, that will comment on videos as like the very first comment, and sometimes even on unlisted videos. So in theory, there should be no way that they would have access to that video, but the comment "wannabe friends" would already be there. So to me, that sounds like there's an exploit in the YouTube API and they have found a way to just scrape unlisted videos, or they're just trying out video IDs and are randomly finding videos and are commenting on them. But the actually scary story to that. Well, first of all, that they shouldn't have access to unlisted videos. But the scary story to that is if you interacted with that comment, if you apparently somebody subscribed to that channel, or if you reply to the comment, the Logan channel or whoever was behind that would take over your account, lock you out of it, and well, I don't know if it was like pay us X Bitcoin to get your channel back or something, but they would hack your channel. The way Evans made that sound was like there was something malicious in that comment itself, where if you, I don't know, looked at the comment on your computer, there would be some malware that, or some exploit that would trigger, which to me kind of sounds implausible at least. It's probably more something along the lines of, hey, the Logan channel is seeing that somebody's interacting with a comment, and this is the next one that we're going to target. How much of that is just Evans, fishing for views, or working with Logan, or whether it's actually an exploit that's happening? Not sure, but what is very likely is that there are YouTube channels being taken over somehow. I don't know. I don't know what to make of it.
Yeah, I need to check that out. I'm really, really interested to see that. But yeah, as I said, it's just scary to see something like that happening. And I would also need a pair of new pants if that would happen. If that would happen to my work, because this is something you put your heart into, and it's basically your living. Well, it's not only basic your living, it's your living.
Absolutely. What was going through my head is here, okay, this is Google that's somehow being circumvented. If it is something that doesn't have anything to do with your account or your password being compromised, if there is such a glaring hole in Google, or in Google service, YouTube, or technically Alphabet, yes, I know. They would be the last guys or the last company that I would expect to have something like that unpatched. FUD, fear, uncertainty, and doubt. Right? That's the vibe that I'm getting from this.
Yeah. Oh man, yeah. So I'm happy that it worked out for her, and hopefully, if it was an exploit, it's gonna be fixed at some point. So we don't have to worry that much.
Yeah, but guys, use two-factor authentication, use a strong password, change it regularly. Just common sense. Yeah. Especially if there's a YouTube channel that means something to you attached to it.
Yeah. I have a problem in 36 seconds because I am currently seeing that my SD card is running out of memory. So I need to change that.
Okay.
Just keep rolling. I will.
Okay. So while Stefan is changing that, I'm gonna start with the next topic here. Researchers create an ultra-fast nozzle-based 3D printing technique. So this is something that was posted on 3D printing industry, and it's a really interesting approach. So typically, when you have a nozzle and you push some filament through it, you actually squeeze it against your existing print, and that gets attached to your previous layers. Now, what they've done, the researchers in Spain, is that they are lifting the nozzle up so far that they can actually influence the jet of filament with a electric field. So they're charging the nozzle and the filament that's being extruded through it, and then are basically deflecting that stream of filament with an electric charge. So basically, it's how the old
CRTs.
The old TVs, CRTs, exactly how those used to work. How those used to work. It's exactly like that. It's just that the energy is a lot lower, and you're not going to get any X-ray smashing through your bed with a stream of filament that's slightly charged.
Yeah. It's an interesting concept, and it looks as if, at least what they have done, the filament thickness is really thin, probably because you should get quite a bit of force if your electric field is big enough. But they printed a couple of like basic shapes, stars and circles, so it's really in the beginning.
The star they're showing is just a crossover from some infill lens, isn't it?
Yeah, it is.
Because, I mean, the core problem that I'm seeing is, like, you're not going to get any sort of sharp corner out of this. Like, they're showing a lot of circles, which is what you'd expect if you just have a sine wave or an electric field shaped like a sine wave. You get nice circles, but sharp corners, I'm just not seeing it.
Well, the question is if in the end that's just a thing of, well, tuning it to get it working properly. Of course, you have inertia, so there will always be some control algorithm necessary that you get sharp corners and things like that. But maybe this is something for like in 10 years that would be able to print faster, print more, well, smaller parts, and maybe even more precise. If you take a look at the precision of a CRT and how
you're deflecting electrons that are flying through that at is it light speed? No, it's not. No. It's not light speed there now. But they're a bit faster than a jet of filament. But yeah, the thing that I'm kind of curious about is how do they keep the filament warm and bonding at that distance? So typically you have your nozzle as close to the previous layer as possible because you don't want to lose any energy, any heat. And from what it looks like, at least in these drawings or these rendered pictures here, is there's at least like a 5 centimeter gap there.
Yeah. Well, you could print in an enclosure that is above the melting point, but if it's above the melting point, also the thing that already deposited on the bottom will melt. Conductive heating? I don't know.
Conductive heating is something that we're going to look at in a different topic. Yeah.
But so they have schematics in that paper, and it shows a power supply between the heated bed and the nozzle. Well, for once, you can use that to charge up the filament, but you could also use it for heating like the small strand of filament that is getting out of the nozzle. The question there is just if you want to start a new line at a different position, how would you handle that?
Yeah, I mean that power supply, I'm pretty sure, is just for the static charge.
Could be.
And if you want an actual current flowing through the jet, you need some sort of a conductive filament, or filament. Every filament is conductive, but you need quite a bit of voltage to get a significant current through a regular PLA or whatever filament they're using here.
Yeah, we'll see. Well, it looks as an interesting concept, and well, it's always the question if it's worthwhile. Maybe there is some more research happening in that field, and it might be something feasible for the future.
Wait a second. So one thing I'm just trying to find out here, is this actually filament? Is this actually a molten plastic, or is it some sort of a resin or a curable material?
Nozzle at high voltage.
Because a nozzle really can be anything.
Yes. Versatility, use of metal or polymer or solvent-based inks, which can I don't know.
I mean, it's something we've just assumed, but I mean, if it is like the polymer jetting that you're seeing, who's doing that? You know what I mean? Where we have basically like an inkjet head.
HP is doing that.
I guess.
Yeah.
Yeah, polymer jetting. If it's that, then I'm pretty sure you can do that with an electron beam, because then you actually have something that doesn't need to cool, or that doesn't cool down, or something that you can actually deposit and shoot out of that nozzle in small quantities.
Yeah. And then you could,
interesting, for sure.
It is interesting. Then you could basically have a jet of like small bubbles of charged particles that you then can deflect using the electrostatic field. And that's exactly maybe a little bit closer to like a CRT works than just having really a strand of filament going down. But what they're showing is like a strand of some material, be it molten or a resin or something like that, going down from the nozzle and then depositing in one continuous line on the print bed.
Yeah, I feel like I've seen this before, but I'm not sure. It might just be deja vu.
Cool. All right.
Let's actually pull this one up. So we've got carbon nanotube filament.
Yeah.
More or less, because it fits into the idea of having your filament heated. Researchers invent technology to remedy 3D printing's quote-unquote weak spot. So this is one from the Texas A&M University in collaboration with Essentium. They've created a filament that they are locally heating before they're applying the next layer to it. And they're using carbon nanotubes. Yay! I mean, do you really need to use carbon nanotubes? I think we've talked about that before. It's like,
it's a cool buzzword for investors.
Yeah, you make carbon nanotubes small enough and it's just charcoal dust. But yeah, basically what they are doing is, or what they're saying is, the weak spot they're claiming here is layer adhesion in 3D prints, in FDM 3D prints, which I would agree is a weak spot. And what they're doing is they are printing a filament that is conductive using those carbon nanotubes, and then they're locally applying an electric current just before they apply the next layer to it. So what they're suggesting here is either having like an actual brush or a wiper that's actually connecting to your print and locally heating it, or through plasma, or I mean, I don't know why. Yeah, okay, plasma. Yeah, you can strike an arc to your print. Yeah, but it's a way to locally heat your parts.
And then, well, improving adhesion at the point where you really lay down the material, that you really have a melting of one layer on the other, and not just that depositing action that not really fuses the layers together. And well, it's always a problem that the polymer chains of the layer that was already there connect to the polymer chains of the one below, and for that reason, it is just not that strong. Yeah.
I mean, typically you just get the heat from the filament, from the freshly laid down one, to kind of seep into the previous one and heat it up slightly. But yeah, for good bonding, you do need both parts to be warm.
Yep.
So yeah, obviously you need a conductive filament to work with that. But I'm pretty sure the general idea you could do with almost any filament. Like, I'm just thinking, like, have a small, halogen bulb or something, just locally radiating heat into that spot.
Or a laser.
Yeah, sure. It's kind of the opposite of a part cooling fan, if you think about it.
Yeah.
Isn't there a printer that actually has a heated part cooling fan that has a very tightly controlled temperature of air blow? Was MakerBots?
I have never heard of that.
But it's basically that.
Yeah.
Right. It's you're somehow locally heating up. In this case, they are directly conducting electricity through that freshly printed part. Yeah, I guess you could do it in other ways as well.
Yeah, and I think in one of the last episodes we already talked about that, because there are patents around which go into locally heating the part using, like, the halogen lamp you just said, or lasers or stuff like that. Yeah, I don't know. Conductive filaments are something that exists, but also come with problems themselves. I don't know if that solves all of the problems that we have, but we'll see. It would be interesting to see something like that at least being implemented in one of the more professional machines, but I don't think that even Stratasys that do a lot of FDM 3D printing do that local reheating. But what I have seen on Formnext by, I think it's a German company called Apium Tech, they have a Peak 3D printer, and in order to get around the patent from Stratasys, they basically have a heated plate over, like, the area where the printer is currently working, and that puts radiant heat into your part and keeping it warm. So you don't have a heated chamber, you only locally heat up the part. I don't know if that also helps with adhesion. Maybe you could even get your temperatures higher that way. But yeah, it has been done a little bit for me as well. I haven't read that you can really get, like, isotropic material properties out of these parts in the end.
Maybe you can with this.
Maybe
we'll see if this. I mean, obviously, this is something that's maybe not going to be available, if ever, to consumers at a price point that's reasonable. But maybe somebody's going to hack something up, because conductive filaments is something you can just freely buy. I mean, Protopasta makes some, for example.
Yep.
So I feel like somebody might just go ahead and try it out. What if we actually do what you suggested earlier, and actually, with a conductive filament, have a current between the nozzle and the printed part? Because that would locally add some extra heat into, because that the nozzle itself is conductive, it would just start heating up right outside the nozzle.
Yeah.
That just add that extra pop of heat once your fresh filament is deposited?
It could be working. I'm quite sure that there is already a patent for that, but yeah. Well, I think one of the problems is that the conductive filaments that we usually see, they have such a high resistance that this might be a, well, is it a problem?
Just add more voltage.
Just add more voltage, yeah.
No, that's not a problem. Always add more voltage.
Yeah, give it a try. I don't know. It would be interesting to see if that really helps. You could just directly print on an aluminum plate or something like that to have just, well, it is the same process as welding, as kind of. And what I have, it is not like TIG welding, like MIG welding, but with MIG welding, you have, do you? It's a bit like MIG welding, but there is a company that is called Virtual, I can't remember, but they invented a 3D printing process where you basically push just a wire. Well, it looks like a normal FDM 3D printer with a print plate that is conductive, and they push metal wire out of the nozzle and have a, well, voltage between the nozzle and the part, which results in the metal wire melting exactly at the point where it is touching. So basically, it is welding, but is it welding?
If you're melting a metal rod to another metal part, I'm pretty sure that qualifies as welding.
It's welding.
Yeah.
But
I mean, this old Tony did some CNC welding. Where we made a little cup or a little tube with a MIG welder on a rotary table. That's actually how I found the channel. I found this old Tony the first time.
Well, but the currents involved in MIG welding. Well, if you take a look at the process, I need to just remember the name. If you see the process working, it doesn't look like normal welding where you have sparks and a plasma and stuff like that. That just really looks like the metal wire is laid down, and at the location where it meets the part below, it just melts in a puddle of material.
Okay. Well, if somebody can point us towards that company in the comments and refresh our memories here, that would be much appreciated. So maybe we can look at that in the next episode and see what exactly that it is.
Oh,
I know that feeling.
Yeah. Just can't remember it. Yeah, if someone knows, please let us know. It's something called like virtual alloy or something.
I mean, virtual Foundry is not it. They make, is it? I mean, I just opened it up. They make like metal filaments, kind of like the BASF stuff.
No, it's not them.
Yeah. Anyways, okay. How do we get here? Conductive pushing current through a nozzle.
Yeah.
Somebody has tried that too. That'd be kind of interesting. But yeah, I can't see how that could go wrong. I guess getting parts to stick to the aluminum would be kind of hard. But then again, if you just have a plain aluminum plate, you also get local heating there if you're not making complete contact. Those few spots that are in contact with the aluminum plate, if you just have conductive filament, those get locally heated and adhere more.
Mm-hmm.
So as soon as you have good bed adhesion, the current spreads out over a wider area and doesn't locally heat that up anymore, or heat it up that much anymore.
Well, if you have a PLA, I think it would kind of work, or you just use a perforated aluminum plate that you get some really, how do you say Formschluss in English?
You get it to interlock with the bed.
Yeah, you get it to interlock with the bed. Yeah. Let's see.
Carbon nanotubes. Okay.
Carbon nanotubes. All right. Next topic. Where is my window?
Miele has published some 3D printing files.
Yes, they did.
Do you have any, back on the topic of kitchen appliances, do you have any Miele stuff?
I have, let me think. I don't have any Miele kitchen appliances. I think at the point when we moved into that house, I did not have the money, but I think currently I would buy Miele equipment if it's a washing machine or a dryer. They just seem to last for like decades.
Right. So for those of you not familiar with Miele, they are like the high-end German appliance brand. Okay. And they have published DIY printable files as accessories for their vacuums, for their cocoa powder applier thingies, and a vacuum adapter for your hammer drill, and a twin adapter for vacuums. So, I mean, there's always that talk about, hey, you can print replacement parts for your appliances if, you know, the most common one is the dial on your washer breaks and you print a new dial. Like that's been done before. That's a fantastic application and it's really simple. But obviously the next step of that would be, hey, this mounting bracket inside my washer broke and I need a new one, and this thing is like 15 years old and I can't get a replacement part. The idea would be you can just download a part, print it, and install it, and you'd be able to service your machine. This isn't that. So these are really just specialty use adapters. I mean, the vacuum flex nozzle, the tiny flex nozzle, that sounds kind of useful. They've got a, what do they call it? Seifenblasen.
Bubbles. Soap bubbles?
No, is it? They've got an adapter for those soap bubbles. Okay.
Soap bubbles.
They've got an adapter for those that you can stick on the back of your vacuum, just onto the exhaust, and just blow some bubbles there. They're saying, oh, the ultra clean stream of air out of the vacuum, because obviously it has a HEPA filter in there, makes perfect bubbles. Okay, I guess that's just a bit of fun. But they've also got some useful stuff, like is that an extra filter for the vacuum, where if you filter up like a lost earring or something, or vacuum up a lost earring, it's not going to get sucked into the bag, but actually just has a little grit there. They've published some more or less useful stuff
on Thingiverse. So, well,
on Thingiverse?
Yeah, they're in Thingiverse. They can only be downloaded on Thingiverse. So if you click the link, you get redirected to Thingiverse. So basically, they are not providing spare parts, CAD for you to print out. Those are just additional accessories, some more or less useful, that you can just download and print out. And some of them seem to be feasible. Maybe it's a good start. I don't know how many really print them out and really use them a lot, but maybe at some point it gets us to the point where there are really things that break that can be downloaded and printed out. The thing that struck me a little was seeing parts that get in contact with food. So the spoon for coffee, and also the small thing you put over your cappuccino that you can drizzle coca over it to get a heart shape.
You can use it as a stencil, yeah.
Stencil.
And that's actually something that Belviger commented on. So yeah, is that really a problem if it's just like reef contact with your coffee powder? Just like scoop it up.
So I gotta be honest, I have been using a 3D printed coffee spoon for a couple of years at home. And
look at you now. Yeah.
Look at you now, and look at me now. It didn't kill me. I think with dry materials, it's less of a hazard, and most filaments are all right for food contact. But the question always is, what did you have in your printer beforehand? How much lead did seep out of your nozzle during printing? We've been at that point before.
Yeah.
And the problem, as I said, that's not such a big problem with dry materials, are just all the cracks and pores that you have on your 3D prints where stuff can just can just stick, and then bacteria start growing there because you're not able to clean it properly. It can be a problem. I think in those cases it's all right and acceptable, but still you should be at least a little bit careful in that regard.
Yeah. So they've actually got a print note on the Thingiverse design. Quote, only use nationally approved materials for the production of this component for food contact. Materials in contact with food must comply with the EU regulations, EC number 1935/2004 and number 10/2011 in the European Union, and with regulations 21 CFR for the American market. Do you know of any filaments that are in compliance with EU regulations 1935/2004 and number 10/2011?
I don't know these regulations, but I have seen materials claiming that they're food safe and they're also FDA approved, or I don't know. So,
food safe filaments on Amazon.
Yeah.
Maker.pla. What? It's like the first thing that comes up. Yeah. I mean, realistically, there's nothing really toxic in filaments, at least not in concentrations where at the instant it gets in contact with like a bit of cocoa powder, it's going to cause any harm. And also the lead in the nozzle. Like there is some lead in brass nozzles, but the amount that can seep out, I think we've done some napkin math on this, is like so marginal. Like walking past an industrial plant probably gives you more exposure to lead than drinking out of a coffee cup made from PLA. But of course, since they are a company, and who knows, somebody might sue them if they don't have that warning in there. That warning is on there, obviously. What they are recommending, though, is printing with PLA. So PLA in a dishwasher is not a great idea. So you would have to hand wash the parts when it comes to like pores and little gaps that stuff can grow in. So
yeah. Some material PLA. Yeah.
So I guess at least printing in PHG would maybe be a better choice, so that it can go in the dishwasher, because the dishwasher gets relatively hot, right?
Yeah, I do have a couple of parts in the kitchen that we, for example, use to, well, put our cutting boards on, that they, when they're drying, not stand in their own water and get really, really dirty and nasty. And I regularly put those in the washing machine. That just helps to keep them a little bit cleaner. But the first batch that I did in PLA did not survive the washing machine. It's totally warped and everything. PTG is better in that regard.
Yeah, I mean, dishwashers, even if you run it on the 30-degree setting, they will still heat up to then dry their content off to, I think, a bit more than 30 degrees.
Yep.
So yeah, that's when a PLA part is going to warp.
Yeah. As I said, I think it's not a real problem if it only comes into contact with dry material. I wouldn't be too happy if they had something that constantly sits in milk or something like that, because that would get nasty so fast.
Yeah, like don't print your baby bottles. I don't think that would be the best idea. Though, if we're honest, like you can get what's the polycarbonate replacement that Tom also has? Not T-glaze. It's so if the bottles that used to be polycarbonate, they're now made from a PET based material, basically. Looks like polycarbonate, smells like polycarbonate, works like polycarbonate, but it's BPA free. You can get that from Tom in filament form, and if you use that with the proper nozzle, I guess that you could print your baby bottles if you get rid of the cracks.
Don't print your baby bottles.
Don't. No. It's still not a great idea.
Yeah. I don't know. I think it's a nice gimmick. Don't really know if that's going to be something that they will continue, or if it was just a little project from an intern, even though these parts are nicely designed. So it seems that somebody who knows CAD did those designs. But, well, where we actually want to maybe get in the future is really to get replacement parts for things that break. But that's a total different story.
But obviously that's against the interest of these companies, because they do want to sell either the replacement parts, which usually are crazy expensive, or, you know, if you can't get replacement parts, new machines. Yep. So, yeah, Kreislaufwirtschaft. Yay!
Cool.
You put a nice topic in here that I guess topic of the week.
Maybe, yeah.
Could be called.
It has that charm. So I put printer maintenance in there because I have been printing, well, my Prusas and my artillery have been running like constantly over the last weeks. They haven't been printing now for a week or something like that, just because we are currently pretty good stocked up in face shields, but they have been running for quite a while. And at some point, I actually got printing issues with my Prusa, with one of my Prusas.
Oh, but the Prusa's supposed to be perfect.
Yeah. So the thing was, I noticed that the bed wasn't running smoothly anymore, and at some point, I noticed that the linear rods. Do you say linear rods? That the metal rods on which smooth rods on which the bearings run, they have been really getting gunked up, and also the bearings themselves didn't run smoothly anymore. So I cleaned everything. I put new thin machine oil on the rods and into the bearings, and everything was running perfectly again. So the question that just came up in my mind was, how much printer maintenance is really necessary? What are the parts that should be maintained? And what is your just, your idea or your thought on that topic? How much printer maintenance do you do?
Well, glad you're asking, because I've got a video on that exact topic. No, I think I've done a video on that like 2 years ago. And I mean, I do neglect my printers quite a bit. I honestly don't do a lot of maintenance. But I've got one of my Mark III sitting here, and it is in need of some TLC. So yeah, as you mentioned, the bearings, linear bearings, those are especially bad because they're constantly sliding on that rod, right? And you constantly get a bit of oil or grease or whatever kind of leaking out. That's something that definitely needs a bit of oil every now and then. The other maintenance that I've had to do on one printer is like the motor bearings were failing.
Motor bearings
because the belt was too tight.
Okay.
But it's along those same lines, right? It's a bearing that is just under load, and maybe if you're overloading it, it does fail eventually. What else? So the one thing that I noticed, when did I notice that? I think in the 8 unboxing stream, is any sort of fasteners that fasten against a plastic part. So whether the bolt head sits on a plastic part or the nut, or the helicoil or whatever is in. No, on a helicoil, I think it would be good. But anywhere we have a pressure of your bolt head against the plastic part, that is going to set slowly over time. So just retightening all those bolts that are tightening against plastic, and just checking stuff that moves, right? So what can actually happen is your filament can wear through the filament guide on top of the extruder, for example, or if it's guided sideways, it can just eat through. What printer have I seen that on?
Well, the Endo 3 type printer, they have mostly their filament right on top, and it goes in a really sharp angle at the lever where the feeder is. And one of my printers actually has that problem that I've also been using for face shields. The Endo 3 Pro has actually a metal insert at that location because it was wearing out for a couple of other people. Yeah, so things wearing through.
And anything that moves, really, right?
Yeah. But what I also have noticed and seen in the past is cleaning your fans and also your heatsink, because that can accumulate quite a bit of dust over the time. And
especially when you're printing PETG.
Oh, yes. I have been printing tons of PETG over the last weeks, which was mainly working really well. And it was, in terms of smell, way more pleasant than printing PLA in my basement. So when I started printing face shields, when I did PLA on 5 machines, there was really always a horrible smell down in the basement. As soon as I switched to PETG for all of the machines, it wasn't really a problem anymore. So I don't know. It seems that the PETG is not emitting as much particles or something like that.
Well, because you can smell it doesn't mean that they're not there.
Yeah.
So just the fact that you get that white buildup on your fans on PETG, I mean, that indicates that there is something significant being emitted from PETG filaments as well.
So what I then had was, after printing tons of PETG, my extruder head was looking horrible, as if a ton of spiders have been living in there, because lots of really tiny, small strings have been accumulating all over it, and even blocking the fan from time to time. So the Prusa has a fan blocking warning. So it actually has the no, it's not it's not PWM. It's the Tacho signal,
which also is a PWM feedback.
It's PWM feedback, and as soon as it noticed that
it's go ahead. Yeah.
Something like that. So I had it happening, I think, once or twice, that the print really stopped and said that the hot and cooling fan is jammed, and I just found a big blob of hairy stuff in there, which, made it not turn anymore. And so I really had to start cleaning all of the fans after every second or third print, because there was always just this
often.
Yeah, but I was also printing PETG at, I think, 250 degrees Celsius, just that I can push a lot of material through the nozzle. It seems to have taken its toll on that, and I didn't notice that before, but this is something that is kind of bad with PETG, and I haven't seen before. But so dusts, particles, strings, they can accumulate, and you should just clean those parts from time to time. If you have those V-slot extrusions with the plastics rollers, there can also be quite a lot of, gunk from the rollers accumulating over time.
Yeah, so you get some wear from, especially if you have the palm rollers.
Yeah,
those do create some dust, and then once it gets caught, it gets compressed.
Yeah,
kind of the same as for the the same thing. It's something that moves. Yeah.
Extrusion.
What about the hot end?
Yeah. Extrusion path.
What exactly? So most. Actually, because I've still got it open, so technically the signal coming back from the fan is a PWM signal, inverted though. It's just called sensor. So PWM typically refers to the input to the fan, how fast it should spin. Anyways, in early designs where you still had hopped bolts that actually had like an M4 threading on them, one of the issues was that threading, because it's kind of knurled around your drive gear, would clog up over time. The newer profiles, and especially if you have something like just a spur gear, those are self-cleaning. So as the filament pushes into those teeth, it kind of pops loose anything that might be in there from shredded filament or something. That used to be much more of an issue. Now it's just like, okay, the geometry is open enough where any gunk will just fall out. But extruded gears can wear down over time.
Yeah.
So especially if you have a threaded brass or non-hardened steel, those can get dull over time.
Yeah.
And then for the harden itself, I mean, on the Prusas, you've got the all-metal E3Ds. Not much to do there, I guess, other than maybe every now and then a cold pull or a nozzle swap.
Yeah. So with the Prusas, I basically had no problems at all besides the sticking bed and the material that gathered in the fan. The only problems that I had was one batch of bad material that constantly clogged the nozzle. So I had to, switch the nozzle and burn out existing ones from time to time. But if you don't have bad filament, I have been printing like tens of kilos of material without any issue of like material gathering inside of the nozzle and clogging it up over time. But I also tend to do quite a lot of cold pulls just when I do filament changes, because then the nozzle is clean right from the start.
Yeah. With Teflon land hardens, though, that Teflon bit that actually goes into the heater core into the heater block, I would consider that a consumable.
Yeah.
Because it does, I mean, it is still a plastic. It does still soften up when it gets hot. So over time, it's just going to deform. And at some point, it's just going to close up at the bottom. And you're going to get some really weird extrusion issues where it's like, it works for 2 minutes and then it stops extruding. Like, what's going on? So that's something, if you have a Teflon harden, that just sometimes needs replacement.
Especially if you're using higher printing temperatures. So I think if you're only using PLA and print at 200 or 210 degrees Celsius, it's not such big of an issue. But also, again, for me, since I have been I have been printing PTG and also PLA at 240, 250 degrees Celsius, I basically had to just cut off the last few millimeters of the PTFE tube every week because it really got deformed and brittle and was causing extrusion problems.
Right. So that's on a printer that has the Bowden tube directly going into the harden.
Exactly, yeah.
Right.
So where it really got
Creality
hot.
style.
Yeah, Creality style.
Some hardens have it differently, where you have a separate piece of PTFE just in the harden itself. And obviously you can't really cut that off because then you're going to have a gap. So on those, you really do need to replace it.
Yeah, but that is also something that just I noticed, and I wasn't really that aware of it, that if you're really printing at the temperature range of temperature, at higher temperatures where you're almost at the border where the PTFE is starting to degenerate, it will still wear out over time. So just keep that in mind.
Prusa have a ASA profile for the Mini, which prints at 260 degrees. Or at least the screen is showing a preheat temperature of 260. Oops. I'm pretty sure it's the same temperature in the slicer. Actually, no, I haven't looked installed. No. But yeah, that is pretty ballsy, I'm going to say.
Well, I think in the end there can be different grades of PTFE, and maybe the cheap ones will wear out quicker, and if you have a higher quality PETG, it might be able to withstand 260 degrees Celsius over a longer amount of time, but 260 degrees Celsius is really just right at the edge.
Yeah. I got kind of scared because in the self-test, the printer itself sets the harden to 280 degrees.
Okay.
but then it stops heating at 180.
Okay.
So it's just like it's setting itself to the temperature and just seeing, hey, I want full heating power. Like,
did you already pull out your gas mask?
Yeah, is Prusa trying to assassinate me here? Like, but okay, it stops before that. So, wow.
Yeah.
So that's the hot end. Beds. I mean, really depends on what sort of a bed you're using, right?
Yeah, clean it regularly. So
yeah,
I mostly print on PEI, and just at some point I noticed that the parts don't stick properly anymore, just because of all of the collection of dust, and also my hand grease while removing the prints. Yeah. So I just regularly clean them, and that's usually fine. Releveling could be something if that's an issue, but otherwise, I don't know. Yeah.
I guess one thing I'm going to add is just double check your electrical connections. Like particularly if there are screw clamps in your machine. And I mean, if there are tinned wires in those, like rip out the tinned end and just get a fresh non-tinned end in there. But just especially the connections of the power supply in hot end heater and heated bed out. Mm-hmm. Like those are some that you probably should be checking and just seeing, hey, are you really still tight, or can it pull you out by hand? Yeah.
I didn't watch your whole live stream. Did you check the connection to the bed of the Prusa Mini?
Oh, that
clamp
fail nut? No, no. I can check that right now if you want to.
Because I'm quite excited. So my Prusa Mark II will get an overhaul probably in the next 2 weeks, just because it has done quite some miles, and I still remember that it is also clamped in the same way as it is on your Prusa Mini. And I'm quite excited to see if I see loose screws in there, and also some problems with the connection heating up.
So this Mini is assembled in exactly the same way that we talked about earlier, or in an earlier episode.
So the cable shoe is not on the copper?
That is correct. So the crimped connectors on the bottom, and it doesn't look like there's copper on the bottom. No copper on the bottom. So the entire current is going through looks like a stainless M3 screw.
Okay.
Which I think we figured out isn't that much of an issue if you look at the resistance of an M3 screw, but could be done better.
Yeah. Well, I have seen that you got, I think, half a ton of filament. If you push that through your Prusa Mini, that might be enough data to see if it's working out for a longer period of time.
Yeah.
Or just use it to heat up your office. Leave it constantly running at 100 degrees Celsius.
I mean, it's really the temperature cycles that would deteriorate a connection like that. Yeah. So I guess I could have it as a stress test. Just leave it running for a week and always have it heat up full blast and cool down. And
probably move the bed always all the time from, to its limits, that you get some stress on the connection.
Yeah, they've got some interesting sleeving on here, which is a heavy nylon mesh, but
isn't that the same one as it is also on the Mark III? Because mine also has this like fibery looking stuff on there.
Okay, they may have changed that because the Mark III I'm looking at right now uses spiral wrap.
Okay, no, yeah, that has been changed.
Okay,
so you're not up to date.
Well, hold on. Do you have a Mark III S?
I have a Mark III S, yeah.
Okay, so yes, this is the original,
but
the OG.
Also in my upgrade kit for my Mark II to the Mark 2.5, there was also this fabric sleeving included.
Okay.
Yeah. So it's probably something they switched right early on.
Right. Yeah. So maintenance, that. Connections, electrical, like I said, just have the double check your screw connections, make sure no wires are kinked. It's kind of like with your car where it's like, hey, optically, visually inspect that the belts aren't cracked and your tires are still looking good and the brake discs don't have any holes in them, like that sort of thing, which nobody does because usually it's fine. But when there is an issue, like you could have caught it.
Yeah. You talked about belts that were tensioned too much. Also, check belt tension from time to time. Just, how do you say that? Just plug your belt, just like the string of a guitar, and see if it makes a sound. And if it doesn't, it might be too loose.
Well, what note do you usually go for?
I
don't know if you guys can hear that.
I'm a really bad musician.
Oh.
Yeah. Oh.
That's pretty high. So the x-axis on the Mini is like a bass guitar.
Yeah, it's bass.
I don't know what note that is, but
do you actually know how Prusa is determining the pretension value that you get after you run the self-test on the Prusa printers?
I believe that is just the resistance that the Trinamic drivers are reporting.
Okay.
There's, I mean, it's not directly measuring the belt. It's just, okay, there's so much resistance on this that now the motor is turning a bit harder, something along those lines. Yeah, that is done through the stepper drivers.
So there is actually fancy belt tension measuring equipment out there, but I have been to the E3D tool changer assembly line last year, and what Gates, so the belt manufacturer, what they're actually providing for their Gates belts in order to determine the pretension of the belts, they have an app that you can download on your tablet or on your phone, and you do exactly that. You plug your belt and it will do an FFT and determine the note that it's playing and tell you, okay, you need to tension it more or less.
That is, but you do need the belt length for that, right?
You probably need the belt length because otherwise it would not work. But this is actually how they're doing it on the E3D tool changer assembly line. They have a tablet there and plugging the...
Well, I mean, it is very accurate. We can measure frequencies very, very accurately.
Yeah.
And, just getting one of those proper tension gauges seems a bit excessive.
Yeah.
For, hey, you bump it once and the tension is off anyways.
Yeah. Yeah, so maybe just to conclude that, it is a good thing to just take a look at your printer from time to time and do at least some basic things, or only just taking a look at it, or maybe just listening to it once or twice in a month. If something's strange, might actually already save you from some trouble.
The thing is, if there's an issue gradually developing, like you're not going to really notice it just by sound or by looking at your print output. Especially when, for example, print quality just slowly degrades because, I don't know, bearings are going bad or something. You're probably not going to notice that. You're going to be like, I thought I remember this thing printing more nicely, but
maybe one thing I could also add to that. Sometimes I'm missing the English words, but sometimes it's good to make maintenance before something breaks, instead of waiting until something breaks and then changing it out. That could be your PTFE tube. Even though your extrusions are still fine, it might be a good idea to just snip off a bit of it and make it work properly again, and not have, well, a big print fail just because at that point you just crossed the border. And this is
preventive maintenance.
Preventive.
Yeah.
Is preventive?
Preventive.
Preventive. Preventive maintenance, yeah.
I've been talking for too long. Yeah, for sure. But I think that goes for anything, like whether it's your printer, your car, your computer, a handful of something is worth. There is a saying for that, which of course I can't recite properly.
All right.
Anyways, I got a comment from Adrian Bowyer.
Adrian Bowyer himself.
Yes, the man himself. Clarifying our confusion about the word solenoid. So apparently what he's been referring to with solenoid, and that's apparently also what's like the official English definition of solenoid, though in my world, I'm not using solenoid that much. It's just a coil. It is literally just a wire wound in a coil shape. And what he's proposing is a static electromagnet. So not the solenoid mechanical. I'm guessing I'm going to get a message from him in a second here that what's that called? But just an electromagnet holding it down, not anything that actually pushes the bed up. So that for heating, and then you turn it off once the print is done and you want to swap out a bed. So that is the clarification from Adrian. I probably made that a lot less clear than the way he wrote it, but yeah. We also got one comment from Bill Campbell. Tom, your hook idea pulling a bed off is going to cause motor skips or loss of position. It's not my idea. I'm just might be Adrian's idea even, but not my idea. Just want to make that clear.
What was the hook idea?
That you basically move your bed, your printer, you turn off those solenoids, you move your bed to the front, it clips into something mechanical there. The printer moves back its y-axis and basically pulls the bed off. Yeah. And Bill is saying, hey, that might cause motor skips or loss of position. Maybe, yeah, probably. But, you know, if there's one time that I don't care about loss of position, it's right before a print. Right. That's when you're homing anyways. Yeah. And yeah, if you have any sort of retention turned off, like it should slide off fairly easily.
Yeah. So.
Yeah. So that's that on the
big
concept from Adrian Bowyer.
The big question is only how you get a new bed on.
Yes.
Yeah. Tray. But.
Yeah. Getting the old one off, I think, is doable, but getting the new one on
might be a bit
tougher.
Yeah. Cool.
Robot arm.
Yeah. Pavel is asking, question, filament width sensor, thoughts? You built one, didn't you?
Yeah, I built a few. Filament width sensor, so that's a pretty broad question, like filament width sensor for testing filaments or for real-time compensation during a print or for determining the quality of that. I don't know. But I'm assuming that question is meant as, hey, should your printer have a filament width sensor and real-time compensate for fluctuations in diameter? And I engineered one. I built one. It works fantastically. There is a weird cycle going on. So when I first designed that sensor, it was for making my own filament, for trying to have a feedback loop there. And I was like, okay, well, that's nice. If only we could real-time compensate on a printer as well. Then like 2 years later, Marlin added that feature that he could just hook up basically the exact sensor that I made and real-time compensate your E-steps for diameter fluctuations. But at that point, filament had gotten so good that it was like, you know, what's the point? Mechanical inaccuracies have more of an impact on how your print is going to come out versus actually on Prusa Mini. It's really cool. Then the marginal fluctuations of the diameter you're going to have. So if you look at this graph that's provided here on Prusa Mini, you actually see the measurements from during the extrusion. And it's rated as 1.75 plus minus 0.015 millimeters. This is their new PC blend. And you look at the graph and it's like, yeah, you can see a bit of wobble, but I would guess that it's just bouncing between 1.74 and 1.76. So there's no point compensating for that, really.
Yeah.
It is such a marginal difference. So yeah, my filament sensor has just been sitting idle. Marlin supports it. You can hook one up. You can real-time compensate, but probably not much of a point unless you're using self-made filament.
Yeah, but I don't know how it works if you have a really fluctuation over a short length. You would need to take into consideration how far your measuring point is away from like the nozzle where you're melting.
That is being taken into consideration, I think.
Oh, okay.
That is in Marlin.
Okay, so yeah, that's pretty cool.
Last time I checked.
But then it would actually need to buffer those values in some way.
And at the beginning of your print, you would not get compensated diameters, especially if you have a long bone. Like you would need to flush out the entire bone length.
Yeah. So, yeah, I actually had the same thoughts. Filament has gotten so well if you're not purchasing like the $5 a kilogram PLA roll from AliExpress. It's usually not a problem anymore. Still, I also experienced similar issues with a quite expensive filament in the past, where the diameter was really badly changing over the roll. But that was probably just due to like the first runs of extrusion where they did not dial it in properly. But still, we need to take into consideration that the usual plus minus 0.05 millimeters of diameter is a variation of 10% in material flow. So if a material is within that specification, it can still severely fluctuate during a print. If that is a problem, you could argue for a mechanical part, I think it could impact the strength of the part. For visually appearing parts, if it's gradual, I think you wouldn't notice it.
Yeah. Yeah, I mean, you can change your slicer extrusion multiplier by 5% typically, and you're not going to see much of a difference, but strength-wise, for sure. But yeah, 0.05 is quite a lot in deviation. Here's me hoping that most filaments are just better than that. So, like I said, this PC blend is 0.015. So 1/3 of that. And I think at that point it's just, yeah. If you have good filament.
The difference in extrusion, depending on the speed that you're printing, is probably higher than the difference in material flow that you're getting due to a change of filament diameter. So,
but maybe it's something I can test for Filament 3.0. Just set up a contraption where it just pulls an entire spool through 2 sensors just to measure it at 90 degrees or 45. Probably doesn't matter. And just get a standard deviation and the diameter profile over the entire spool length.
Yeah. And compare really cheap filament against, I don't know, Prusa Mini or some other brands that praise themselves with having a small diameter deviation.
Yeah, or just verify what they're putting on the box.
Ooh.
And make sure that, because these are printed for every single spool, right? These are measured, and you get the QR code that you can look up the details for that spool in detail. Yeah, and that would be something to verify.
Cool. So if we're not seeing something from you being posted in the future, you have discovered something and can't tell that to the world because you're a Prusa shill, or
no. It's just going to be a while until I have Filament 3.0 done.
Yeah. I actually tried to do the same, but my filament-width sensor didn't work probably as well as yours, because I wanted to do the same for my filament extruder. But I need to get back to that. And maybe I either adopt your setup or just do it in a different way.
If you need the plans, they're out there on the internet somewhere.
I think you have sent me them already. You're using...
Or that. I may have sent you a complete sensor even.
I think not a sensor, but we have already talked about you using a Hall sensor or something like that.
Yeah. So it's an analog Hall sensor and a magnet, basically removing the magnet in and out. And you can measure that. You calibrate it once with like a drill bit, because those at least you can verify with calipers. And you have a lookup table. It's actually the same. It's code literally ripped from Marlin, that lookup code. That just sees, okay, this is the value I'm getting from the Hall sensor, and then linearly interpolates it between the values you've calibrated in.
Cool.
And that gives you, I'm going to say, pretty good results.
Okay.
From what I've seen.
Interesting. All right. I think that's it for today.
Pretty much. Yeah, I guess one last thing. We got one more complaint about name pronunciations.
Okay.
So Manic, I know Wheat is complaining about that as well. And yes, I've intentionally mispronounced it again. Let's see how many variations we get out of this name.
All right, Tom, it was great talking to you again after almost 4 weeks of not doing a podcast. I hope the next one is going to be earlier. Well, yeah.
I'll be busy, but I'll
be
try
busy.
to find time. Oh, I just unplugged something. I guess that's the perfect moment to call this one good. All right, Stefan, thank you for the time as well. What do we say, guys? If you like this, subscribe on YouTube or on your favorite podcast platforms. You can find our patrons linked below if you really enjoy what you're doing. And yeah, thanks for listening.
Yep. And we'll see you in the next one.
Goodbye.
Goodbye.